In section 3.5, they have these problems here where they want you to sketch the graph of the equation using extrema, intercepts, symmetry, and asymptotes. Then use a graphing utility to verify your result. I didn't use a graphing utility. Basically, I think for most of these I just used algebra. Didn't even use calculus, just to graph if it was not necessary. If it's rational, a fraction, like x terms divided by some other x term, I just use what I remember from pre-calculus algebra. Okay. So for this one, the vertical asymptote, set your denominator equal to 0, you get x equal to 1. For the horizontal asymptote, it's x divided by negative x. That gives us y equal to -1. What about any intercepts? What happens when x is 0? When x is 0, we get y is equal to 0 as well. So that's good. Good to know. Now what I do is just divide the number line or partition it based on the x values, the x-intercept, x equal here to 0, and then also when x is equal to 1. Just look at the signs on this interval with respect to y. So just take a number from -infinity to 0. Let's take -1. We get negative. Here we get 1 minus a -1 is positive, so this is negative. Take a number between 0 and 1. Let's say 1/2. So this is positive. 1 minus something positive is positive. And then take something bigger than 1, like 2. So we get 2 divided by 1 minus 2. That's negative. Now the graph, the strength of it is really with respect to the straight line. The graph is with respect to the asymptote, so we got x equal to -1. So x equal to 1, excuse me. And then y is equal to -1. So we have an intercept. It touches down at the origin. The graph is negative from -infinity to 0. This is the origin here. And then from 0 to 1, it is positive. So it's doing this. It's riding with respect to the asymptote. And then from 1 to positive infinity is negative. Now my sign is negative and positive here only is reflective of y, that is, of the function. So this is not the derivative. So here, this is when y is positive or negative. So if y is negative, that means the graph is below the x-axis. If y is positive, that means that the graph is above the x-axis. Here, y is negative, the graph is below the x-axis, and then it hovers and it rides along with the asymptotes. This is the x-asymptote, vertical asymptote, x equal to 1, and then this was y equal to -1. I mean, that's the graph. Move on, right? Okay, here, notice that the vertical isotopes is ±2. horizontal asymptote, the power of our numerator is 1, the power of our denominator is 2. So here, if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is always the line y equals 0. Notice that if you set y equal to 0, implies that you have x plus 1 equal to 0. That is x equal to -1. So I'm going to divide the number line based on here the x values of concern, the critical values. So plus or minus 2, and then x equal to -1. And we measure what happens to y. So take a number less than -2, let's say -5. Plug it here, we get -5 divided by positives, that's negative. Take a number from, it's -1, between -2 and -1. Let's say -1.5. It's going to be negative up top, and then we have negative downstairs, so that'll be positive. What about from -1 to 2? Let's take 0, get negative. Anything bigger than 2, we have positive. So we have y equals 0, which is the x-axis, and then plus or minus 2. So we have here, remember this is -1, 0 is an intercept. Then we have other intercepts. If you let x equal to 0, y is equal to -1/4. Intercepts. Right, so -1, 0, and again this is x equal to -2, x equal to 2. The x-axis, y equal to 0, just labeling our asymptotes. And then we have intercepts at x equal -1, 0, and then 0, -1/4. So let's see how this is counted. From -infinity to -2 is negative, so it's below the x-axis. From -2 to -1 is positive, it's doing this. And from here, from -1 to -1 to 2 is negative, it drops down. So it's doing that, and I missed my intercept there, which I always do. I never like to plot the point because I miss it. And then from 2 to positive infinity is positive. That's the graph. Number 63. Look at this guy. This is x squared. This is x squared plus 16 is always positive. This is one of the examples of the witch of Agnesia. And it looks like the bell curve. Sometimes it's like opposite, upside down, whatever. So notice here that we have, it's too thick. x equals 0, y equals 0 is the intercept. Here, for the vertical asymptote, there are none. X squared plus 16 does not give us. Set x equal to 0, we don't get any real number. What about the horizontal asymptote? It's going to be 1 divided by 1. The powers are the same for the top and the bottom, so we divide the leading coefficients. So that's y equal to 1. Right? This graph is always positive. You see that? This graph is always positive. Well, that cuts down some of the work for us. And we need the y-intercept, y equal to 1. So we touch down at the origin. This is the x-axis, y-axis. This is the line y equal to 1. So the graphs always hover. They try to ride along the asymptote, and it will touch down at intercepts as well. Right? Drops down to pick up the intercept, then it continues to run back with the asymptote. Okay, for this one, x equals 0 downstairs will give us a vertical asymptote. Now, if you recall from algebra, that 2 gives us the limit as x goes to 0, and it also serves as the horizontal asymptote. Because if you add these two fractions together, you get 2x squared minus 3 is divided by x squared. They have the same powers, second power upstairs and downstairs, so the horizontal asymptote, or the limit, is the ratio of the leading coefficients. 2 divided by 1 is 2. Now if you set y equal to 0, we have 2x squared minus 3 all over x squared set to equal to 0. That implies that we have 2x squared minus 3 equal to 0. That is, x is equal to plus or minus the square root of 3/2. Okay. So I partitioned the number line based on these x values of interest. 0, this negative square root of 3/2, and then this positive square root of 3/2. Take values for x and plug them into y to see what sign do I get. If x is going to be, if the graph is going to be above the x-axis, it's positive. The graph will be below the x-axis if the sign is negative. So let's take over here, let's say -5. So we put that negative there, it becomes positive, positive, positive. Take a number between negative the square root of 3/2 and 0. Very small number. So let's take something smaller than that, negative wise, and plug it there. If you do, then the denominator is always positive, but if you do, you're going to get a small number, and so it'll be negative, comparable to that -3, right? So negative, same thing happens there. And then over here, take a number bigger than that, like say 5 squared, 25 times 2 is 50 minus 3, positive, right? I think that's all you need to get the graph. Where's the guy that I'm using? What's that? The vertical asymptote is x equal to 0, or the y-axis, and then y equal to 2. So let's see. We have intercepts here, negative square root of 3/2, comma 0, and positive square root 3/2, comma 0. X-intercepts, right? Now, x cannot equal to 0, so we don't have a y-intercept. So this is the x-intercept there and the x-intercept there. So from negative infinity to this x-intercept here is positive. It's doing that. Then from that x-intercept to 0, it drops down below the x-axis. From 0 to, it's just symmetry, right? We'll get the other side. From 0 to the positive square root of 3/2, it's negative, so it's below the x-axis. So it's doing that. And then from this x-intercept to positive infinity, it goes above the x-axis, but it does not cross the y-intercept. It just rides along with it. Okay? And that should be very familiar. Thank you. Let's stop there and go to Curry's in Decatur and get a chocolate cream brownie, something like that, fudge brownie with cheese cream stuff, something that you shouldn't have, but every now and then it's good to reward yourself. Thank you.